Hello friends, today I am going to take a session on Internet of Things. We are going to understand in detail about the IoT ecosystem, its its architecture with the help of some applications. So today we are going to learn about what is IoT, how did it originated, how did it evolve, how from where did it evolve, the complete roadmap of IoT and the applications that are being used in present life. Every day we are using it. We are going to talk about the different applications of IoT, and at last we are going to discuss about the architecture of IoT in detail. So let's start with this session. First of all, it would be very interesting to know that what is IoT basically. So IoT basically is a network of physical objects that are all featured with some unique IP addresses, and they are all connected with internet connectivity. And so there is a basic communication of within the IoT architecture, where the physical devices, we call it as a things, are all connected with internet enabled devices, and they are connected with your system. So there is a complete flow of communication in IoT. So basically the IoT creates an intelligent invisible network fabric that can be sensed, that can be controlled, that can be monitored, and that can be programmed. And these kind of IoT enabled products, they are employed for embedded technologies, and that actually allow us to communicate directly or indirectly with each other with the help of internet means. So what is basically an IoT? In a very simple words, we can say that a network of internet, there are two words that are very important in this. One is the network of internet, and that are connected with different objects, and these particular physical objects are called things. So one is internet centric devices, another is things centric devices. So a network of internet connected devices and objects that are able to collect and exchange the data, right? And that is how the word abbreviated is IoT, right? And you can see in this diagram, you see that across the world that we are seeing that many devices, when we are going to connect it, so it will become a concept of internet of everything. So these three circles helps us to understand the concept of internet everything. That is where the technology will be unveiled with the help of internet, and you will be implementing these technology for different applications for executing different business functions that are viable for marketplace. So it can be anything. It can be for environmental purpose, it can be for manufacturing purpose, it can be for agricultural sector, it can be for financial purpose. So you just identify the domain, right, and you just try to implement this technology for getting out your objectives further. So how did it evolve, right? It would be very interesting to know the roadmap of evolution of Internet of Things. If we see in the history, in the past, that the era of pre-internet, there was a communication between human to human, right? So then at that time, like the mobile technology was there, SMS technologies were there, and then came up the smart networks with the concept of WWW, and that is Internet of Content. With that, we were able to communicate efficiently with the help of emails and other entertainment medias. And then this network got well advanced with Web 2.0 architecture, and now it is Web 3.0 with all different types of web services. We are using it for different purpose like e-productivity, e-commerce, etc. And then from web, we are now we have already moved up into the smartphones. That means everything is becoming portable and flexible with the help of mobile applications. So we have also started integrating the web systems, web design, web applications with the mobile applications, and that is where we find out the content with the concept of Internet of People for social media. And nowadays we are using it, exploring it with the platforms like Skype, Facebook, YouTube, Twitter, and many other social media platforms. And then later on, this concept got evolved with the enhancement with connecting the devices, and that is where machine to machine concepts came. IoT is actually beyond the machine to machine concept, where it is actually connecting different devices with the means of protocols, domains, and internet, right? So it can be used for many purposes. It can be used for tracking the devices, it can be used for identifying the object, it can be used for monitoring and controlling process, and many other applications. So it would be very interesting to know that from where did this word IoT got originated. So it was just in 1999, Kevin Ashton in the Auto ID Central, he just used this word first time for Procter and Gamble in the context of RFID supply chain. So when you see the roadmap of IoT, you will find the evolution of this word Internet of Things was originated from actually the supply chain of Procter and Gamble that were using RFID technology. So during that time, onwards, during the same year, Auto ID Labs were able to introduce the RFID systems for EPC, that is Electronic Product Code. And later stage, LG in 2000 also introduced their first internet refrigerator. But from above all, if you see in 1982, there was a prototype that was experimented by Coca-Cola, and that was implemented by some students of Carnegie Mellon in 1982. Actually, they used the refrigerator, and they connected the refrigerator with the internet. Some of the basic purpose were to count the stock, to check out the stocks, to perform some research, market research, to perform some usage statistics, and to monitor the temperature, right? So you can see, and then at later stage this concept was enhanced, and it came up with the new word that was used by Kevin Ashton in the Procter and Gamble lab, in Auto ID Central lab, and that was Internet of Things. So the evolution of internet was made up with 4 different areas. One is all connecting devices were featured with some physical address. So we call it as an IP address, where all objects are being identified with some unique IP address. And apart from this, there were some inexpensive and powerful hardware that were used for, like, say, node and sensors, right? And with this, the performance with the connectivity and the performance was a concern, and then lots and lots of data were also being generated. So the concept of cloud computing system was also integrated at later stage with the Internet of Things concept. And so in totality, you can say it makes a complete architecture of IoT with the integration of big data and the cloud systems. So like if you can see the figure over here, right, it would be very much amazing figure where you can see this particular technology is going to enhance in such a way, right, that there is not going to be any limit, right? So these technological limitations are receiving the exponentially when billions of things, you can see, just imagine this figure out, where all different types of billions and trillions of devices are going to get connected with each other, and that is how the future will be digitized and automated. So you can see the roadmap of IoT, right? It has started with RFID. Before 2010, it was basically used for home and personal use, and at later stage, beyond 2010, you can see the use of this concept was actually also adopted by the enterprise level for different purpose. Especially they were using RFID for security and privacy purpose, and for many other usages, right? And apart from this, during 2015 to 20, you can say that it was also adopted for utility purpose, and many other applications were introduced, and actually they are introduced in especially say energy and harvesting and recycling sector. Large scale wireless sensor networks were developed. Highly enhanced security was also adopted with IoT. Cloud storage was also enhanced, right, for online analytics. There are many different tools available for implementing the analytics within the cloud systems. And you can say many different applications in different sectors were adopted for different purpose. And again, you can see that there is a broad future, right? There's a vast future, very bright future in 2005, and we are going to see so many things that are going to get connected with the internet concept, like say smart traffic system is there, auto car driving it will be there, right? Intelligent transportation and logistics systems will be there, where we are going to see some concept of plug and play smart objects, right? So you can see here there is some statistics which will help us out to understand our future, that is going to get surrounded with all different types of IoT devices. So it was just predicted in 2018 by IHS that you can see the flow of the growth rate of the devices that are going to get connected. You can see by 2020 it is 30.73 billions of devices that are going to get connected, and by 2025 it is going to raise by 75.44 billions of devices. So it's a very huge scope, and there is a huge opportunity to build up a career in IoT also, right? So as we can see that there are different applications that we are using every day, like say we are using IoT for healthcare, we are using for smart infrastructure, we are using for smart transportation and logistics, we are also using it for home automation, we are using it for health and safety purpose, we are also using it for security purpose, right? So many different applications are available for from Internet of Things. So let us understand that from three perspectives. One is industry point of view, one is domestic life, and another is infrastructure. So there are so many applications as we have discussed. The concept of for industry is called industrial IoT, right, where you can use the concept like pick and place robotic arms can be used in assembly for managing the inventory stores, and within the factories for construction machineries, different logistics for tracking the vessels, right? Uh, and going to the domestic life, you can use you can automate your home appliances, you can control your smartphones, you can manage your robots, right? For many different purposes, right? From infrastructure point of view, the IoT is also going to be very useful not only to the limited sector, but it is going to cover up all the sectors, especially the aviation industry, railroads, automobile sectors, and right now automotive sector is it is going to adopt a lot of devices, and we are looking at this forward in the coming versions of car, right, SUVs, right? So there are so many applications. Let us discuss them one by one. So first application, you can see that this is the IoT enable home with all devices and appliances that are connected with each other. So you can see within the home, you will see that a smart grid system, garage door opener, security systems, smart thermostat, automated lighting, smart appliances, pool sensors, gas water meter, then you have e-meter, then sprinkler system. So all appliances are connected with each other, and this is how you can control it even from remote places, right, with the help of technologies. This is the example of home automation. Another example can be beacons. This is one of the best example right now which are actually used in retail stores, You can see the sketch of the retail store. This is how it looks, where someone can use it for measuring the distance. You can see within the wall there is a beacon that is being stuck. You can say another beacon is there and another device through which you can measure the distance, right? This is one of the application of using beacons that are actually used by architectures. And another use in the retail store, you can see this is the retail store where the one who is going to purchase the next devices, you can see the beacon will give you an information about the product in your app. So where you can get the information about the schemes and which are running out right now in the store. So this is how the IoT is being useful in retail stores, right? For traffic monitoring and controlling system, right, you can see that the great revolution is going to come, which is going to help to come up. The driverless car concept is going to come, right? Smart traffic monitoring system as a concept of smart city is going to come, where it will guide you and help you to process some alternate routes within your traveling path, right? And even there are some surface technologies that are also going to come, which is going to be integrated with the system. So a complete smart solutions are going to come, right? And which will help us to guide our day-to-day life process, right? Apart from this, the smart healthcare system is one of the critical applications and very important also, where you can see here when the patient is in very emergency, the doctor, how you can see how they are going to diagnose with the systems the patient and how they are getting the information. So you can see when they are taking them into the near OPD, the administrator is all the devices because they are connected. So the administrator will come to know about the information of the patient, and they will once the information is being entered, they will the near ones, the family members will get an alert, right, that one of your member is in emergency. So this is how the health and safety issue, the emergency cases can be handled with the help of IoT devices. Now, IoT devices are also used in manufacturing industries. We call it as an industrial Internet of Things. You can see in 2018, it was $1.78 billion. So the business with the cumulative growth rate of 40%, it is going to be it is estimated figure, it is going to be $12.4 billion business by 2024, and out of them 60% of the market would be from factory environments, and from this the discrete manufacturing is going to be the biggest segment, that would be followed by the process and batch manufacturing process. And Asia is going to be the most biggest potential region for IIoT platform, right? So this is going to be the very bright future and revolutionary stages of the modern digital era we are going to see in the near future. So we can see that there are many other applications, like say for renewable energy resources, for sustaining the environment, saving the nature. We can use different applications of IoT, like water power leak detection, to save the water, to save the nature, to help the environment to get pollution free environment, right? So monitoring the weather, right? In the infrastructure, like smart buildings, we can have thermostats, lightnings, presence sensors, smart lock systems, right? Smart meters, smart plugs, all different types of appliances, smart appliances are going to come in the near future. right? Likewise, you can also take an example of smart cities. Traffic management was one of the area. Water management, lighting, monitoring and security purpose are another areas of smart cities, right? So apart from this, you have smart energy, right, for different, like say fault detection. That is the one of the biggest solution which you can help it out in preventing some big disasters, right? So there are many other applications like smart living, smart industry, then smart health, right? So many applications are there, and many things are going to come in future. Especially we are going to see the future technology of wearable devices. You can see there are a lot of list of wearable devices that are going to come in the future, and according to the Gartner prediction, we have some figures that the wearable market is going to be increasing. So in 2016 there were 28.3 million units of IoT devices, and by 2020 they are now 82.5 million of IoT devices. And this is, I am not talking about every devices, I am only talking about the wearable devices of IoT. And you can say all, like say head, neck, arm, torso, feet, entertainment, fitness, smartwatch, location and tracking, all different types of applications are going to come in that are related to wearable devices. Apart from this, we have some applications for home automation, like accessing the control, managing the light and temperature, managing the energy optimization solutions, predictive maintenance, we centrally connected appliances and all. So lots and lots of applications are going to come in future, but there are very popular platforms that actually helps us to build up these kind of applications, and some of them are ThemeWorks, very popular. We have everything: Cumulocity, Oracle, Caryats, Aries and Ethereos, right? Apart from that, we have LoRa framework, Exelta is there, Archisa is there, Exosite is there, and many other different platforms are available, right, where you can develop your IoT devices. Now let us understand the basic architecture sequence. What does IoT architecture include? So first and very important part of this IoT architecture is its hardware requirement. So the hardware requirement includes the node and sensor, right? Apart from this, you have cloud communication. Within that, you have data streaming process, storage management, event processing of the data which you receive from the hardware, and applying some intelligence and performing some analytics over those data. And you can bring up all this analytics on your you can build up some UI, and you can bring up all this analytics on your dashboard, or you can use it some tools which are available, right, for analytics purpose. And again, at last, the security is also going to be the very most important point, and also it is going to be the challenge in IoT in near future. So let us start with the basic architecture of IoT. There are different phases of IoT. Let us divide this figure into three phases. So you can see the first phase, we can see the down phase, that starts with sensor and actuator. This part is called hardware phase of the IoT architecture. So this includes sensors. There are different types of sensors that are being used, and actuators are being used. And apart from this, sensors and actuators are integrated with the board. There are different types of board that are based on microprocessor and microcontroller, right? They are being used, and when these board are integrated with the sensor, this sensor reads the data, right? It reads the data from the surroundings, and it will send that particular data to the gateway, and with the help of RF components that are Zigbee, Z-Wave and BLE. So with the processing automation for the resource management and communication with the node to gateway, right? The communication happens with the RF component, that is radio frequency component, that is Z-Wave, Zigbee and BLE. Apart from that, you have many other protocols which are used for communicating the gateway and the node. So here the gateway will become the most important intermediate of communication between the cloud and the node, right? And when the gateway receives the data from the node, it will send up the data to the cloud system. This is the cloud system. With the help of the connectivity, either you can connect this system by Wi-Fi or you can connect it with the GPS, right? So again, the protocols that are used to connect the cloud and your gateway are MQT, CoAP, you can use it HTTPS, and you can use XAMPP. There are many protocols that are coming, and you can use the particular protocol for your purpose. And within the cloud system, you have the data streaming process that will receive and store the data into the database, and with that you apply some event processing of that data, and you come up with some analytics, and you take some decisions based on that data, right? So it all depends. This is the basic architecture and common architecture for any IoT devices, and you can add up your own you can customize your own architecture as per your need, but this is the basic one and you can add on with this. So let us start with the communication flow. Let us take an example of this. Say for example, we are taking example of smart irrigation system. So where you have a sensor, like say we are using soil moisture sensor, that is able to detect the water level content, right, within the soil. So in smart irrigation, some plants and crops require some level of water. So if the level increases, there will be some impact on the production of that plants or crops, and if the level decreases, then again it will suffer. So to prevent this kind of loss, so and to improve the productivity of your agriculture, what you have to do, you can use this kind of technologies where you can use the sensor like soil moisture, and you can automate your agricultural process with this system. So the communication flow happens like the sensor will collect the data, it will send it to the gateway where it is connected with some protocols with say Wi-Fi system or GPS system. This data will be sent to your control center, right, where this will be connected with some actuator that can be your water pump. So if you feel when the soil moisture senses that yes, the water level in the plant has been decreased, so it will send the data, right, to the control center where you will be validating that particular data, and you will be deciding with your event processing, your business logic, you will be applying some rules to your engines, and accordingly you are going to allow this actuator to act upon, right? So this is the basic communication flow, right? And your data continuously will be stored in your cloud system, that when at what time the water level was decreased, how much water was being poured by the water pump, when the water pump was started, when it was gone off. So all types of data will be stored and collected in the cloud system. So this is the basic communication flow in the IoT architecture. So we have talked about the different hardware requirements. So because the hardware are going to be playing a very important role in your IoT system. So there are different nodes. We call it as a board. There are two different types of nodes. One is ARM based and another is AR. So one is microprocessor based, another is microcontroller based. So you can see there are three boards I have identified. One is basic board, that is Arduino R3 board, which is our microcontroller, and another is also microcontroller, that is Node MCU, but it is integrated with the Wi-Fi system. So these two boards are microcontroller, right? But if your requirement is very higher for machines for manufacturing purpose, for high-end processing, you may need to use Raspberry Pi, that is microprocessor, right? And apart from this, there are many other boards like BeagleBone is there, Atmel is there, Galileo is there, and NanoPi is there, right? So many other boards are there, right? You can use and select your board as per your need to your IoT devices. Now sensors. Now there are many different sensors are available for different purpose, right? You can see for measuring the temperature, for humidity. There are acoustic sensors to measure the sound and vibrations. There are chemical sensors for measuring the gas and pressures. There are some series of chemical sensors like gas, like to detect the flammable gases, to detect the toxic gases, right? And apart from that, there are many other sensors like accelerometer is there, gyroscope is there, MEMS are there, right? That is micro electromechanical devices, right? These are the small chips that are used for machine industry, especially the CNC machines. Right now they are using it for improving the efficiency of the machine and optimizing the time of the production, right? And apart from that, there are many other classifications based on which you can use the sensors as per the need. So there are electrical sensors, there are proximity sensors, optical sensors, navigation instruments, flow and fluid velocity sensors, environment, weather, moisture and humidity sensors, chemical sensors, the sensors that can be very useful for transportation and automotive sector, and other sensors like acoustic for measuring the sound and vibrations. So these are the basic classifications of sensors where you can use them for your different purpose. Now, as we have discussed that there are some protocols that are used to communicate the node to gateway and gateway to server. So there are protocols like Zigbee, Bluetooth low power energy devices, Z-Wave, Insteon, Dash7, Google Thread and many other that are used for connecting your node to your gateway architecture. And there are some protocols which will play a very important role to connect your gateway to server. So here server can be your local system or it can be your cloud system, right? You can use it HTTPS, MQTT you can use CoAP, you can use XAMPP, you can use IPv6 low power wide personal area network, you can use TCP IP or UDP protocol based on your requirement, right? So there is a complete cloud system over here, right? You understand the different components, the protocols that are involved to connect the gateway and architecture and the cloud components. There are some tools which are available like AWS, Microsoft Azure is there, IBM, Cisco. The purpose of cloud system would be to receive the data streaming process with the help of web services, to store the data in the database. You can use any of the data. It can be RDBMS, it can be NoSQL. You can process the data for some kind of events which you want. Like say you can use once the data is in your database, you can use and process those data for your purpose. Like say you want to identify an object, or you want to identify the motion of the object, you want to measure the distance of your object from the system. So many other applications are available, many other technologies are available. You can use NLP, you can use machine learning technologies for by implementing the system. You can apply the patterns and intelligence with for generating some analytics, right? For taking some business decisions, right? And with the UI development, you can make up your web UI and you can make up the mobile applications where you can build up some dashboards where your analytics will be displayed and the data will be portable to you even in the remote places. And this is how the data streaming, this is the data streaming tools like you can use Tomcat, JBoss, WebSphere, Mosquito, Node.js with the help of TCP IP protocol. These are basically used for streaming the server, right, that is connected. Once it is connected with the gateway, actuating the process and taking the updates continuously from the gateway, because at every like say milliseconds, or you can set up your own time, The node is going to send continuous data to the gateway architecture, and this data is going to be immediately transferred to the data to the cloud system through web services. Now for data storage, you can, again, as I told, you can use RDBMS or NoSQL. There are different tools which are available. You can use like Redis is there, you can use Cassandra, you can use MongoDB, right? Many other tools are there. Even you can use RDBMS data like Oracle and MySQL. There is no restriction on using any particular type of data, but it should be based on your need, your application. Then for event processing, as I told, if you want to perform some real-time analytics, you want to detect some object, you want to process, you want to apply some quick process to identify your object which is nearby to you, at what distance it is, to measure the dimension of an object, right, for processing and streaming the different patterns of the object. So you want to make it out some decisions from the data which you have received. You may be applying some rules, you may be applying some rules to get some notifications for security and alert system, right? So you may be using different technologies like machine learning, as I told, natural language processing is there, and with the help of many other tools that are already available for machine learning technologies, you can use them and you can apply them for your solution, right? And apart from this, you have analytics. There are different tools that are available for analytics. The data which you are going to gather up, you are going to apply some intelligence. You are going to convert that particular data into information by applying some intelligence. And for that, there are some tools like Hadoop ecosystem is there, Spark is there, D3 Tableau is there, TensorFlow is there. Many other tools are there which will help you to process your real-time data, right, and to give up some good visualization in the form of dashboard analytics. With this analytics, you will be able to take some business decisions, right, and you can just develop some good UI to show up your analytics in the dashboard. There are some tools like ThinkSpeak is there, but if you want to customize your own requirement, then you can build up your own UI. In these particular UI technologies, some front-end technologies like Angular and React JS frameworks are being used to develop the device management system. Even you can use backend system as per your requirement. This is for like applying some business logics to your data. You want to apply some visualization, right? So there are many purposes where you can develop some web UI as well as some mobile applications for portability. So there are different phases we have studied up, but the security is one of the biggest concern of this, and there are different areas of security concerns. One is the physical devices. Like it can be stolen up, it can be modified, it can be replaced, it can be cloned, right? And in the software, there are some issues of security purpose. It can be modified, especially the firmware development, right? So if you have to very much think about its security before planning up the architecture, right? So once the IoT device has been built up, the security is the big challenge. So security part has to be thought of while you are actually designing your architecture for the product, right? So many other solutions are there, means many other challenges are there related to the security, but there are also some advantages. And one of the major advantages, you can say that with the help of technology, you can automate the process and you can optimize your processing time, right? That is going to help you to reduce your manpower, and you can utilize those resources effectively in many other different purposes. For enhancing your businesses, for improving your business process, right? And with again the advantage of the technology is that you are going to get a lot of data, for which you are going to use that particular data into taking some business decisions, right? So major like the improved customer engagement, technology optimization, reduced waste, and enhanced data collection are going to be the major benefit of IoT technology. Talking about the career opportunities in the IoT, there are many different roles and specifications in IoT, where it is a multidisciplinary role you have to play in that. Looking at the architecture, you can see there is a role of embedded engineer, there is a role of the person who is knowing embedded systems, who is knowing the firmware development, who is able to understand about the network policies, right, who is able to understand about the cloud computing systems. Within that, they must be able to know about some technologies for event processing like machine learning technologies, NLP, big data analytics and all, right. So there are lots of opportunities on this, and accordingly there are different roles that are being identified. One of the popular is robotic specialist, another is cyber security analyst for securing your IoT devices, another is neuro implant technician, then you have cloud architect, you have data scientist, right, you have virtual reality design, many other machine learning scientist, right. So many other job profiles are there that are connected with IoT jobs. So let's explore IoT in future. Thank you all of you. Thank you very much.